I'm recording a cut, but my bad. Okay, so what I mean by clockwise, I'm gonna restart this. So think of this as the hands of a clock. So we have a clock here, like a little clock hand, right? And this clock hand is rotating clockwise. So it's like, let's say this is a clock hand right here, and it's going this way. When it reaches that way, you notice that it will touch this A line, going like so. See how it just touches it? This right here is our bearing of of A from C. Going back to our U shape, that's literally what happened here. A mistake most people would make is they would think of this a bearing line like this. But that is not what the bearing is. That is not true. Think of it as each bearing being hands of a clock. So what should the angle be for this hand clock to like point at that direction? That's pretty much what a bearing is mostly. It's think of it as like hands of clock, and as it goes clockwise, it goes one of the hands of the clock goes towards the point. Right. So now that we know that, what other important things do we need to know? Say we have this U shape. Right? So it can be any U shape, but the main things you need to know is that if it's a U shape forming, where these lines are pointing towards north, the addition of these interior angles will always be 180. Alright, very important. So, what's next? I think it's about time we do a few bearing maths to make sense of what I'm trying to say. Let's see if I have any interesting bearing maths for us to do. Should be one. Alright, this one's a really good one. Alright, so how does it look like? Well, firstly, we have 4 towns. So we have town A, B, C, and D. So let's first draw our diagram. It's a straight line here, straight line here, it's another straight line. So like that, straight line here. This is C, this is A, this is B, this is D, this is 12, the length, this is 12, no, this is 15, not 12, my bad. This is 15, and this is 8. So, first question says, calculate the distance from B from C. So from C distance to B. A very important thing, this whole line right here is pointed north. This is because in the question is written B is 12 kilometers due north of A, which means B's line is in fact going north. Please read these statements where they mention what is north, what is not north. But mainly what you need to know is that this line, this B line right here is north. Alright, so anything from this B line, since everything else is perpendicular, it's the other sides. Okay, so yeah. Why is this important? Because we define distance between B and C, which is this distance, right here. So what is this distance? Notice how this forms a right. Notice how this forms a right angle triangle. See that? See how it forms a right angle triangle? That's important. The reason why it forms a right angle triangle. Oh yeah, it's so much better, right? So this forms a right angle triangle. And what does that mean? It means we have to use SOHCAHTOA. Let me change this out. That makes it look nice. Okay. So SOHCAHTOA. So we think of this as theta. Well, actually, no, we don't even need SOHCAHTOA. We can use Pythagorean. A little thing, if you're using right angle triangles, always remember the Pythagoras, which is just A, B, C, A, where C is the hypotenuse, So C is always just root over B squared plus A squared. So we have to find the BC, which is the hypotenuse. How do you know it's a hypotenuse? It's opposite of the 90-degree line. That's the hypotenuse. Any line opposite of the 90-degree line in a triangle is the hypotenuse. So what is the hypotenuse? It's this formula here. You can think of it as C. This line BC is the hypotenuse. If that's the case, that means it's BC is equals to root over A squared plus 12 squared. And the result gives us is 4 root 13. Now this is not the important part. The important one is the second question, where it says to find the bearing of A from D. So what's saying? It says to find this A from this D, right? Exactly. So what is it? Think of it again. We can actually, for making it much easier for you guys, what I recommend doing is to imagine a 90-degree line right here. Like imagine a 90-degree line, a perpendicular line that's going north, right? And we can imagine the hands of a clock, right? We can imagine first we imagine the perpendicular line going north, like so. I think putting it in white makes it confusing. Let's put it in red. Or actually, no, this color looks nice. Say this is our imaginary north line. That's not straight or north looking at all. Wait, let me just go. Perfect. Imaginary north line. And there's the hands of a clock. Okay, it's in a point towards A. So it's in a point towards A. So we're gonna have an imaginary hand clock that's gonna point towards A, and it's gonna go clockwise, right? So it's gonna go clockwise. We find this total angle. Right. So how do we find this angle? It's not really that hard actually. Here's how. First and foremost, we need to remember that this side right here is 90 degrees. Okay? So this is a right angle triangle. If you don't see it, then I hope you see it. This is a right angle triangle. The diagram is really bad, but this is a right angle triangle. So the important part is that since these are all perpendicular to each other, this part is already 90 degrees as well. Right? This part is also 90 degrees. So all we need to know is this angle. What is this angle? We can use SOHCAHTOA. How do we know it's going to be SOHCAHTOA? It's very simple. It's that this theta is the hypotenuse. This is the hypotenuse. From here, this is the opposite, and this is the adjacent. And so we have to find theta, and we have to use the lines we have, the opposite and the adjacent. What has the opposite and the adjacent? Tan, TOA, opposite, adjacent. So we're going to use tan theta is equals to 12 by 15. Theta is 38.65. Okay? But remember, that's not the answer. That's just this line right here. This is 38.65. We need to know the total angle, which is this whole thing. And we know this right here is 90. So it's 90 plus 38.65, which gives us 128.6. That, ladies and gentlemen, is this total angle. It's this whole total angle right there. So that's that bearing question. Let's do another bearing question. This one. It's interesting. Alright, now this one's a scale drawing math, so I'm probably going to use a scale. So this scale right here. I don't know how to turn it. That's the problem. I should figure this out though. but it's a scale math, so that's why it's important. So let me go to 90 degrees at first. Let's see. Firstly, it says, let's first actually just draw our diagram, right? So we have a straight line. So let's just keep the scale actually. Let's make it 90 degrees. It's fine. It's fine. It's a bit hard to use the scale, so just do that. Where is my thing? I'll select. Okay, there we go. It's selected. All right. So think of this straight line right here, right? Then we have another line going like this, and then we have another line going up here. We're going to clear a few tabs to make it easier. Alright, this is better. So now, it says to first, to remember that the scale is 1 centimeter is 75 meters. Take the measurement taken from the diagram to find the actual distance between T and S. Oh, I should label this. This is T, by the way. This is S. So first, you use your ruler to measure, right? So you can use the ruler to measure whatever you get. But since this is a scale diagram, and I don't have a scale, I'm not gonna explain what this is, but you just use a ruler and measure it. But what I'm gonna tell you is the very important thing is that fountain F is situated 450 meters from T. From T, 450 meters, and is on a bearing of up 210. This is important. So you want to take your ruler, right, let's move this ruler up here, and you want to make it sure it's perfectly straight. They're exactly 90 degrees. This is very hard. There we go, 90 degrees. So take this line right here. So make sure this line is exactly 90 degrees. And okay, this is really thin. I think I should increase the thickness. Oh, that's so much better. So let's take this line. Take the red line. Take this line and make a 90-degree line across. Right. So we have a line like this. This is our this right here is like our line, right? This is our north line. This is our north line. So what you want to do is you want to take from this north line, right? And you want to take this as 90 degrees. So you want to rotate this. Let's just rotate this. It's going to go 90 degrees on the other side. Full horizontal. There we go. 0. This is exactly what we wanted. We want this to be 0 degrees. But this is showing 0 degrees right here. But from here, it should be 90 degrees. Basically, you put a protractor sideways. So to make things more sensible. This 0, think of this 0 as 90. So far I can't turn it directly 90, but this is, you say, 90 degrees, alright? So what you do here is that you take it as, this whole thing is 180, right? This whole thing is 180. So this whole thing is 180. Let me just remove it. think of this whole thing as 180, right? This whole thing is 180. Then you measure slightly more until it's 210. So just slightly more until it's 210. Then you just label it. That's all. So that's basically it for most of bearings. Just the basics, of course. I'm not really showing any complicated math. I'm just showing you most of the basic forms of bearings and a bit of trigonometry. So that's it for today. But before I leave, I should mention I was supposed to show the solution for this monstrosity. So that's what I'm going to do now. So let's solve this monstrosity. Just copy this and the way. Right. So here's all of this. Let's solve it. Firstly, we need to break all these down into the most simplest of forms. Secant is 1 over cosine, so 1 over cosine 2 theta. That was an alpha for some reason. 2 theta minus tan is sine theta, sine 2 theta, by cosine 2 theta. Cosecant is 1 by sine 2 theta, right? This is equals to root over 3 by 2. I should bring my worksheet to be sure, I think. So I can double check. Hold on. Bring it. Okay. Let's see. So let's start though. That's the unfortunate part. Oh, I have the solutions. I have the solutions. Okay, it's fine. I'll see the solutions later on, but it's 2 solutions, I think. So next step is 1 by cosine 2 theta minus sine 2 theta by cosine 2 theta multiplied by this becomes inversed. So this becomes sine 2 theta by 1. So it results in 1 by cosine 2 theta minus sine square 2 theta by cos 2 theta is equals to root 3 by 3. Root 3 by 2. This becomes 1 minus sine square 2 theta by cosine 2 theta. 1 minus sine square 2 theta can be written as cosine square 2 theta by cosine 2 theta. Cancels out to just cosine 2 theta equals 2 root 3 by 2. This has a range of 0 to 180. So let's put the range down from 0 to theta to 180. We're going to multiply everything by 2 to make it possible to take inverse. Less than equals to. I need the calculator. Let me just pull the calculator out. Let me go get the calculator real quick. Okay, so 180 into 260. Alright. 360. So now we have the ability to take inverse, because they match the range. Cosine inverse, root 3 by 2. Make sure it's in degrees, not in radians. See, my one's in radians, so I almost made a mistake there. So another important thing, cosine is positive. So we again write down ASTC. Positive, negative, positive, negative. Positive means first, and cosine means last. So it's A, whatever the value of 2 theta is, and 360 minus that value. So cosine inverse of root 3 by 2, that is not root. 2, yeah, 30. Okay, that's nice. So 2 theta is equals to 30 degrees and 360 minus 30 degrees. So 360 minus 30, we get 330. So 2 theta is equals to 30 and 330. So theta is 15 and 165. I have to double check the answer though. I could be wrong, in which case that's a problem. But if I'm right, then it's nice. Yep, there it is. 15 and 165. 15 and 165. That's the answer. So that's the solution for the little homework I gave you guys. Today's homework will be none, because no homeworks. Anyways, that's for today. See you later. Bye-bye. And get that A star.